longtime on-air host, joined with one of my favorite hosts, I suppose, if all things are considered, Steve. And we've got a wonderful guest with us, too, to talk all things machine learning training. Steve, introduce yourself to the people, please.
All right. Buttery flattery will get you a long way with me. Hey, everyone. I'm Steve Roberts. I'm a developer advocate for .NET and PowerShell at AWS. And Manny, please introduce yourself.
Hi, I'm Khanuja, and I'm Artificial Intelligence and Machine Learning Specialist at AWS.
Manny, we are probably two of the least qualified people to be on this broadcast with you right now, but I'm so excited to learn more about machine learning. I'm not an expert by any stretch of the means. I do know enough that usually there are about 3 stages to machine learning, right? You got to have a lot of data and you got to clean that data. Then you move on to training a model with that data. Then you move on to deploying the model and actually getting inferences from that model, predictions, if you will. But we're here to talk about training, right? Mm-hmm. What is training a model? What's entailed in that? What do I do? How do I get started? What do I need to know?
Yeah, that's actually a very interesting point, because once we have our data, there is a lot that goes into training our models. First, we have to select which model do we want to train, which will solve our business problem. And then we also have to, once we have decided that, then we have to optimize our model, meaning fine tune our model, select different knobs and see which will work better, and then find the right objective metric, which can be accuracy or reducing your loss, right? So those are some of the things that goes into training a model. And when we have done that, so we literally call that, tuning our hyperparameters is like more of experimentation. So a lot of experimentation goes into it. And once we have done that experimentation, we also need to understand and look into how our machines are being utilized during the training. And also, if my model is overfitting or underfitting, then I don't want to go through and the entire training process. I just want to stop my training job. So these are like a lot of things that goes into it. I've just touched base some of those things which are very important, like selecting a model, fine-tuning your model by selecting different hyperparameters. And then that's what experimentation is, recording those experiments and also getting insights into your training jobs and the machine on which the job is actually running.
Cool. So like I'm on this learning journey for machine learning, right? And I can only imagine that for real world or state-of-the-art machine learning models, these models are big, right? To help with improving accuracy. I mean, do we have any difficulty in dealing with large models? What's available to help us?
Yeah, so especially when we are talking about deep learning models and state-of-the-art transformers models are really, really popular with that. And they are huge. They are so huge sometimes that they might not fit into your single GPU memory. So when we are talking about training those models, then we literally have to divide our models into a number of GPUs. And let me tell you, that's not simple, because you literally have to know what my model is, what is the architecture, what are the different layers, how do I, divide it. So if you're doing it manually, I mean, that's like, or on your own, that's like a very tedious job. But with SageMaker, and specifically SageMaker Model Parallel Library, it provides automatic model partitioning. So it makes our job easier.
That's cool. I mean, I know from the app dev world, where I feel a little more at home than the machine learning world, doing distributed computing in general is not easy, right? Sharding a database, sharding Kafka, doing any type of microservice distribution, it's tough because you've got workloads running all over different places. You have to make sure you've got the appropriate amount of compute and memory and all these different things for each of these different workloads. It sounds like that's a similar problem in the machine learning world. So it sounds like the GPU is the unit too that I'm going to be, there's memory and compute on the GPU. How do I decide how many GPUs I need for distributed training that I'm going to do with a model?
Yeah, so in our SageMaker developer guide, we have actually have some estimate on how you can, again, it's an estimate on how you can, calculate the memory requirements. And let me share that with you. It's more about, so let's take an example over here. Let's say that we are using mixed precision with floating point 16, right? So think of it floating point 16 as it takes 2 bytes to store it, right? And if we are using Adam optimizers, then the required GPU memory per parameter is about 20 bytes. And that's the whole calculation that has been done, but it's just an estimate when you're using this. So that gives a good idea. So for example, now if you have a really big model, which has 10 billion parameters, for example, and with our estimate, if it takes 20 bytes, you will be like thinking about 200 GB for sure, right? And
Yeah.
so these models, they are growing in size, but the hardware is not catching up, right? So uh, I haven't seen a GPU, single GPU with 200 GPU. It will be too expensive also, right? So that's where, sharding our model into different GPUs or the different nodes is important. So that's how you can use this as a quick estimate, like when you have like 10 billion parameters, and that's about.
My head's exploding at the idea of 10 billion parameters. I'm sorry, I just can't envisage this.
No, and that's a smaller one. So we actually have a blog which people can go through, which talks about training a model with 175 plus billion parameters. That's a popular GPT-3 model for natural language processing. And
Wow.
now these days, people are even talking about training a model with trillion parameters. So it's growing fast.
That's amazing. I mean, part of this to me is, even if we do have the GPU there, right, that can meet these quality, we're never going to get away from this need of optimizing. The way that I understand it, at least, and this may be incorrect, I hope it's not, but like I used to work in storage back in the day, and when you're uploading a large file over the internet, right, you typically cut that file into pieces and use what's called a multi-part upload, right? And it's because same problem exists with a network, right? Your network speeds are only going to get to a certain level at some point. If you could parallelize that, it'll go faster, right? Is that kind of the same idea here? Is that what we're talking
Yes,
about?
that's exactly the same idea over here. And let me explain that with a small image that I have. So when we are talking about model parallel, what we are basically talking about is that I have, let's say, one machine, or if we are talking about in terms of AWS, so they are like machine learning EC2 instances. Now, my one EC2 instance can have multiple GPUs, right? So in this particular image, you will see 3 GPUs, but usually you have like 4 GPUs or 8 GPUs or 1 GPU, right? So now in the context of model parallel, what we are saying is that we are dividing our model into these number of GPUs. And when we talk about model, think of model as a network, right? Which has different layers, right? So that's what we are trying to showcase over here is this layer 1 and layer 4 might reside on GPU 1, layer 3 might reside on GPU 2, and so on. So how do we decide which layer will go into what GPU? So with SageMaker model parallel, you actually don't have to worry about that because you can choose to do automatic model partitioning. And what it does behind the scene is it will basically determine the architecture of your model, the entire model graph. It will then determine the number of parameters, weights, and the tensors that it has. And then based on that, it will basically run a automatic model partitioning algorithm to place the different layers into different GPUs. So a lot of that heavy lifting that you would do it manually, you can actually choose the auto partitioning parameter and use that. You also have an option if you want to manually do it. There is an option with the SageMaker model parallel library, but I prefer automatic partitioning.
It sounds like it would be super convenient. I mean, you mentioned there that we've got our EC2 instance that's got multiple GPUs, potentially multiple layers on each GPU, but there's also nodes. Where do those fit into the picture? How would I specify the number of nodes that I have, for example?
Yeah. So when I was referring to nodes, I was referring to a single GPU, right?
Okay.
So one is that you can have one instance and that has like 4 GPUs, so there are 4 nodes. Or you can also have like 2 GPUs and each GPU has 4 nodes, then your world size will become 8 nodes, right? And
Okay.
just a pro tip over here is if you have such a big model and I can start with 4 GPUs, one instance with 4 GPUs, and I feel that I need more number of GPUs, I would say go with a single machine which has 8 GPUs. The reason is because there is a communication overhead as well. When these models get trained, they have to talk to these different layers, right? Because the way the machine learning model, especially the neural network, works, it's sequential in nature. So you first have to, the data will pass through these different layers through a forward pass, and then it calculates the activations, and then there is a backward pass which does the gradients and updates the weights and all. So there is a communication that is involved between these different nodes. So that's why it's recommended that use a bigger, if you really need 8 GPUs, then use an instance with 8 GPUs. But if you need more than that, feel free to add another instance of another 8 GPUs to make a world size of 16.
Just throw more GPUs at the problem.
So that's another thing, right? We can throw more GPUs at the problem, but then one part is the GPU memory, the other part is GPU utilization, right? So when we have a bigger model, we are talking about GPU, because these models are difficult to fit. So we're talking about GPU memory. But then are we able to utilize our GPUs appropriately, right? So that's where the memory saving techniques of SageMaker model parallel literally comes into play.
Yeah, I mean, this sounds to me, not to belabor the S3 analogy that I made, but this sounds like instead of using the AWS CLI to upload, something to S3, I could go do this manually, figure out like the multi-part, breaks and do it and do all the SHA, hashing and all of that stuff. But no, the CLI just does it for me, right?
Yeah.
Sounds similar to the SageMaker model parallel feature as well, that it'll do this for me. I had a question though about the layers themselves. If one of the layers itself won't fit onto the actual memory of the GPU, is there something that I can do about that? How do I approach it when it won't physically, like just one of the layers won't fit onto the GPU memory?
Yes, absolutely. That's very important. So what I'm showing currently on the screen is that that's called pipeline parallel degree, where we are deciding that how many GPUs we want the model to split into, right? So like how many shards of my model I want to place. So that's pipeline that you can set with pipeline parallel degree parameter. And what you have just asked is that's what we have in one of our memory saving techniques, which we call tensor parallel degree. So you can actually specify that. And then if your layer is like big that it cannot fit into a single GPU, then you can use tensor parallel degree to split the layer itself into multiple GPUs. So, and just a quick pro tip over here is that your tensor parallel degree that you are setting should not be greater than the number of GPUs on one instance. So for example,
that makes sense. Yeah. I was wondering though, is there any automation in having that layer span GPUs? I mean, does SageMaker help behind that? If I set, for example, the maximum number that a layer could span, does SageMaker do work behind the scenes to make that so?
So the way SageMaker works is you only provide your tensor parallel degree, and then it will you can specify like I want 2, then it will just split your layer into 2 GPUs. So that's what is provided right now from SageMaker.
Yeah, what I was thinking was like if I set 4, for example, right,
Mhm.
and the layer would fit across 2, would it fit across all 4, or would it leave it at 2 and then leave the other 2 to do other work? You can tell that we're learning in this whole system.
Yeah.
It's like every time we do one of these sessions, I feel like I now have a whole new session I need to go and figure out some stuff.
Yeah. No, let's skip that question, to be honest.
What about other memory saving or optimization
Mhm.
techniques? I think you had a notebook that you wanted to show us at
Yes.
some point, right?
So there are certain memory saving techniques that you can use in addition to tensor parallel. So I will share that notebook on how you can set up those techniques. But just to name those techniques, we actually have a really good blog post on it. So, and the link will be provided, I think, in the video later. So these techniques are optimizer state sharding, activation checkpointing, and activation offloading. So I will talk about these when we'll do a walkthrough of our notebook. So let's take a sneak peek over here, and then I'll talk about what is like optimizer state sharding, what is activation checkpointing, and what is activation offloading.
All these terms always sound way more complicated than they turn out being, and then when you explain them, Monty, I'm just sitting there going like, "Oh, I get it now.
It's
Okay."
this. Yeah.
Yeah.
Game doesn't give me much though, because I don't know these words. So I'm happy you're here. Thank you.
Yeah, so that's what we are here for, right? To
Totally.
explain these terms and make it easier for our viewers as well. Okay, so I'll go through the notebook and we can see how we can, enable these parameters when we are basically running our distributed model parallel training job. But just to give an overview, so when we are training a deep learning model, there is an optimizer which is involved, right? So what happens is that this optimizer has a lot of weights and weights associated with this. So what happens is with optimizer state sharding, when we say optimizer state, we're actually talking about the weights and stuff like that. So when we say we are sharding, then we are basically dividing these weights into different GPUs. So with SageMaker model parallel, you're dividing the model. You also have to divide your data as well, because your data can also be big. So there are two aspects. One is the model parallel degree that we have talked about, and then there is data parallelism degree. We also call it as DDP. So we can enable that. So with the optimizer state sharding, it uses the data parallel degree, and then it shards the state, basically divides the weights into those number of GPUs. So that really helps because we are again saving, since we have divided, we are trying to save the memory. The second point is activation checkpointing and activation offloading. So for people who are not aware what activation really is, so when we have a deep learning model, again, it's a graph, right? And we have a number of layers in between our big neural network. And then we have this that our data will go through our neural network. And when our data goes through the neural network, that's the forward pass first. So then we calculate the activations during the forward pass. Those activations need to be stored in the memory because during the backward pass, these activations are used to calculate the gradients. And then what we are trying to do is, because if we are saving these activations in the memory, then we are using our GPU memory. So activation checkpointing helps you in basically releasing the memory when the activations are not in use. And then to go further, activation offloading, because all the instances, if they have GPUs, they also have CPUs, right? So why to make them sit idle? Why not use them? So activation offloading goes further beyond, which is basically offloading your activations to the CPU memory when they are not being in use. And as you're moving through the backward passes, it automatically loads them when they are needed. So those are some of the activation, some of the memory saving techniques. And this blog post actually goes through them in detail to basically explain what these parameters are. And I'll personally share this, and the viewers at home can actually go through this notebook that we have, which basically talks about these hyperparameters in detail. So we have training script and we have other helper scripts in there. But just to give you a sneak peek, and we also have links to the model parallel guide for SageMaker. So definitely check this link out. And that was the link that I was using when I was sharing the estimate of the memory and all. So it's already there, right? So let's go through the hyperparameters. So these activation checkpoints and everything that I've explained, you actually have to enable those.
Okay.
So these are the parameters for the memory optimization.
Yes. So like shard optimizer state, you can set to true. Okay. Activation checkpointing set to true. And then the stuff that I talk about, activation offloading, can only be enabled if activation checkpointing is set to true. And then we have these another, then you can define your tensor parallel degree and pipeline parallel degree that I already talked about, and your model parameters, and then define your training job. And then you can run your training job. So there's like a lot that goes into running a training job, specifying the experiment, your model parameters, your hyperparameters, and so on. So, but I hope that gives a good idea to our viewers who are listening to this, like what are those memory saving techniques that they can really use.
Yeah, that's great, and it's handled for you too by SageMaker, which is even better for me.
Yes, I vote for that.
Yeah,
and you might have to use, modify your script. But if you are using like Hugging Face, which is a model library for transformers, very popular. They have a lot of pre-trained models. Then you can actually use a SageMaker Trainer API, which for your training script that you provide while training the model with SageMaker. And it does a lot of work for you, like distributing your data and setting up, and you are only focused on providing these configuration. But if you want to have your own training script, then in the documentation that I talked about earlier, there is actually a link, like over here, you can go, and then it gives you steps on how you can modify your own training script. So
that's great.
Yeah, so I would highly recommend to go through this, and it also talks about some best practices and all. So that's like very much recommended to walk through.
That's wonderful. Mani, I'm so sorry we are out of time, but you've given us so much to go get started. Seems very easy to get up and running with this parallel feature in SageMaker. Just a few parameter changes and a lot of blogs, a lot of resources that you shared with us. So thank you.
Yep.
Please come back another time. We'd love to have you back on the show, and stick around for more from AWS On Air.
Well.